Hello friends, in this video we are going to discuss the diode resistance of a PN junction diode. Hence, diode resistance can be defined from the IV characteristics or VI characteristics of the diode. As we know that diode is a nonlinear material, that's why it will have some different resistance. So let us first classify the diode resistance. Diode resistance are of two types. The first one is the forward resistance. It is of the order of 10 ohm to 100 ohm, and the next one is the reverse resistance, and it has a very high value, nearly greater than or equals to 1 meg ohm, because as I0 is increasing with temperature, so the reverse resistance RR will decrease with temperature. Now, this forward resistance of the diode means the resistance of the diode in the forward bias division, and reverse resistance means the resistance of the diode in the reverse bias condition. Now, this forward resistance of the diode can be classified into two groups. The first one is the DC resistance or the static resistance, and the next one is the AC resistance or the dynamic resistance. So, we will denote this DC or static resistance by capital R suffix F, and we will denote the dynamic or the AC resistance by small r. Now, let us define what will be the static resistance or the DC resistance of the diode. Now, DC resistance of the diode can be found from the forward bias characteristics. So, the forward bias characteristics looks like this. In the y axis it is YF, in the x axis it will be the voltage across the diode. So, the characteristics looks like exponentially increasing function, where this is the cut-in voltage. Now, if I take any point on the IF and draw a parallel line on the VD, let us assume this current as I dash, and let it will cut the characteristic at some point, and from that point if I draw a parallel line with IF, then it will cut the VD axis at some point, let the name is V dash. So, the DC or the static resistance can be defined as RF is equals to V dash by I dash. So, this V dash by I dash is the static resistance or the DC resistance of the diode in the forward bias condition. Now, let us look at the dynamic resistance of the diode. So, the dynamic resistance of the diode is denoted by small r. This small r is equals to eta Vt divided by If. From this equation we can write, and we know that Vt equals to Kt by Q, where Vt is a thermal voltage. So if I put the value of Vt, then I will get eta Kt by If into Q. So this is the final equation of the dynamic resistance or the AC resistance of the diode. Now we know that eta value is 2 for silicon material and eta value is 1 for germanium material. That's why we can say that the diode AC resistance for the silicon will be greater than the diode AC resistance for the germanium. Hence, from this dynamic resistance, we can calculate the dynamic conductance of the diode also. So, dynamic conductance of the diode is denoted by small g. And as we know that the conductance is nothing but the reciprocal of the resistance, so we can write the dynamic conductance G is equals to reciprocal of the dynamic resistance, that is R. And we know the equation of small r from here. So if I put the value of small r, it will be Q into If divided by eta Kt. So this is the final equation of the dynamic conductance of the diode, and where G is proportional to the forward current. Now if we want to draw the equivalent circuit of the diode in the two different condition, that is the forward bias condition and the reverse bias condition, then it will be the equivalent circuit of diode in forward bias condition. So let us take a diode. So this is the P side and this is the N side. Now if we connect positive potential here and if we connect a negative potential here, then the diode will be in the forward bias. That's why this terminal is called the anode terminal and this terminal is called the cathode terminal. Now as we know that in the forward section of the diode or the forward bias of the diode, there is the characteristics like this. Vd is the voltage across the diode and If is the current flowing through the diode. Then the diode characteristics look like this, where this is the cut-in voltage. Now we can say that every diode or PN junction diode in the forward bias section will have some forward resistance. So let us denote the forward resistance by Rf, and there is a cut-in voltage always be across the diode operation, and the current will be flowing in this direction, and across the diode we will get always the V gamma potential. So we can say that there will be always a V gamma potential across the diode. So this is the V gamma and this is the cathode terminal, this is the anode terminal. So this figure is the equivalent circuit of the diode in the forward bias section. Now sometimes in the examination, if Rf is not provided, that means the diode is ideal. then we can draw this circuit in the following manner. Anode V gamma K. So, this is the equivalent circuit of an ideal diode, and this is the equivalent circuit of an practical diode. Now, let us see the circuit or equivalent circuit of a diode in the reverse bias section. As we know that in the reverse bias mode of the diode, the resistance of the diode in the reverse bias section, that is capital R, small r, is very much greater than or equals to 1 meg ohm, because a very little amount of minority current will flow across the junction of the diode. So, if it is connected in this fashion, so it is P N, this is cathode, this is anode, and a negative potential has been applied here and a positive potential has been applied here. So, we can say it is a reverse bias mode of the diode, and very small amount of current, minority current, will flow across the diode. That is why we can say the diode resistance in the reverse bias section will be very high and of the order of 1 meg ohm. So, the equivalent circuit can be drawn like this. So, there will be an anode and there will be only the reverse bias resistance of the order of 1 meg ohm, and no voltage drop will be there. So, it is the anode and cathode. So, this is the equivalent circuit of the diode in the reverse bias mode. So, this is all about this topic. Thank you.